using our heuristic. And if you remember, we did this a little bit in our session. We discussed this a little bit in our session. The heuristic we're going to use is the Manhattan distance. And our Manhattan distance is going to be our heuristic or our best guess. Basically, you can think of this as like a GPS, guessing the fastest route. And the reason it's called the Manhattan distance is because of the thought experiment that we have here. So think of yourself at First Street and First Avenue in Manhattan, in the city of New York. You want to get to 4th Street and 3rd Avenue. You can't go diagonally. So you'd walk up 4th Street first, that's 3 blocks, then over to 3rd Avenue, another 2 blocks. So you've walked a total of 3 plus 2 equals 5 blocks. And that's what this formula is doing. The absolute value of A0 minus B0, and again, A would be our starting point, B would be our ending point, and we say 0 because just like in our grid, or in our Manhattan example here, we have X and Y coordinates. So A0 minus B0, the absolute value is just a way of saying we're going to take any negative number and make it positive. So -3 would be 3, -10 would be 10. So the absolute value of A0 minus B0 is our vertical distance from our start and our end. And the absolute value of A1 minus B1 is the horizontal distance. We add them together and we get our Manhattan distance. Here's a further explanation of this. So here's our grid. Think of this like a small piece of the city map. S represents our start point, E represents our end point. We're using X to represent the path. So we are on, say, 2nd Street and 2nd Avenue, and we want to go over to 5th Street and 4th Avenue. So we're going to go down 2 and over 3. Actually define our heuristic, right? So outside of this, let's actually use it. First, we're going to say priority equals new cost plus our heuristic. We're going to send it over our goal as an argument in the next cell. I'm going to put it up here. So we're going to say define heuristic goal. Actually, we're going to say AB like we did in our example there. We're going to say A, B. Okay. All right. We're going to return, as I said, the absolute value of A0 minus B0 plus absolute value of A1 minus B1. Okay, so that's what our heuristic is going to do. It's going to return the Manhattan distance. All right, so now that we've defined that, we can go back down here and continue writing our A-star algorithm. So now that we have the priority, it's calculated using our heuristic. Remember, we have, and our priority can also be defined as our F cost, if you remember the video. So F cost or priority is equal to G cost plus H costs, right? Remember, go back to the video if you've forgotten. F costs is equal to the G costs, which is the new cost that we calculated up here, plus our H cost or our heuristic costs. Right, so moving on. Now we need to add this next cell to our frontier with its priority, okay? So we're going to, here, now that we've calculated the priority, we're going to say heap Q. Up here we popped. Now we need to push onto the Q. Heap, push. And remember, frontier is the list we're going to push onto, and we're going to push on a tuple. And in that tuple, we need to send it the priority that we have just now set based on calculating the F costs. And then we need to give it the actual cell. So whatever priority this is, that's calculated, and then the cell that we're looking at. Okay. Now, what we need to do is update where we came from for this square in the came from dictionary. Okay. All right. So I'm going to say came from next cell equals current, right? So when we get into the loop itself, we pop off the current. That's what we're looking at, and then we're going left, right, up, and down for each one of those cells. Left, right, up, and down. The next, we're going to assign it to the variable next cell, where all of these cells that we're looking at came from the current cell, right? This cell came from the current cell. I hope that makes sense. All right. Finally, what we want to do is we want to color in the squares with yellow to show that this next cell is a candidate for the best path. Again, this is just to observe what's going on where we're running the code. We're going to say pygame draw.rect screen. We're going to color these yellow so you can see them as a potential candidate. And we're going to have a tuple here of 4 items. Make sure you have cell size, and then next cell 1 times cell size, and then next cell 0 times cell size. Okay. And just as before, we need to do a pygame display update. And then pygame time delay 100. All right, Now, after this for loop runs, what we want to do is reset the stage. So we're going to redraw. We're going to clear all these green and the green current one that we're looking at, which with the highest priority, and also the potentials that we colored yellow. So we're going to clear that. We're going to say here, we're going to reset the grid. We're going to set grid for next set of checks. So whatever the next priority is all the way up here at the top of the while loop, we want to reset the grid so that it gets highlighted with green and we don't have the previous priority or the previous thing that we were checking highlighted in green. So we're going to set grid, we're going to run the set function that we created again, and we're going to give it the start and goal. Okay. All right. So now, once all of this is finished running and we actually have our the current equals the goal, the final thing that we want to do is actually return the dictionary, the came from dictionary, because once the current reaches the goal, the came from dictionary will have a list of all the cells that lead back to the start. So I'm going to go back again. So make sure this is on the same line as the while loop. Okay. And we're going to say return. We're going to return the came from dictionary, which allows us to reconstruct path back to the start. Okay, so you're going to return came from. Okay, and assuming I don't have any typos, we can actually run this and see what we get. I do have a typo somewhere on line 71. Where's my typo? Pygame display update next so comma pygame display update. Where's my syntax error? Draw right screen yellow. I know where my syntax error is. I'm missing parentheses here. Okay. And I'm probably missing one on 119 as well. Down here, 119. Yes, I'm missing a parentheses there. And then I'm missing one in 124 here as well. Okay. All right. So now we can actually look at our album. And just as I said, if you press any key, it should start. Okay. We have a bit of an error here. Let's see. Tuple object not callable. This was on line 118. I think we have another typo. Okay. So to not use current times zero, current zero times cell size. So this is a tuple, but I'm getting the 1. So there seems to be an error here. Let's close this and stop the code and see what the issue is here. It was on 118. So it said something about a tuple. Let's see what that might be. This looks fine. Might be missing something obvious here. Getting and current. So the current should be a number, cell size. You know what it is? I'm missing a comma here. I'm also missing a comma here. So this is the surface we're going to draw on. This is the color. Then we have a tuple with what we're going to, for the coordinates for the squares. Okay. So let's run this one more time. All right. Press a key. There we go. Press a key again. We get a noob start and end, and it's searching and it finds it. Start and end. I'm searching. The green is the priority for checking. The yellows are the potentials that we could check, okay? And it works. Searching green is always the priority that's coming off of our heap, okay? And then when we get to our goal, we backtrace, all right? So I'm going to stop this and show you, as I said before, that you can increase this because everything is based on these constants. Increase this to say 20. The code should work just the same, just with a 20 by 20 grid instead of a 10 by 10 grid. Okay. All right. So now, okay. And again, remember the green is the priority and the yellows are the potentials, the next cells. If you remember from the code, the green is the current. And then we're searching left, up and down and recalculating the scores based on the distance, the heuristic that we use to calculate the F cost. Okay, and that's basically it. You can play around with this, and of course, as I said, with your homework is to add obstacles to your grid here.